In this video, we'll discuss points, lines, and planes. Now, a point is an exact location in space. There's no size or shape, but we will sketch a dot there to help us represent that location. And to help us understand that location, we will give it a capital print letter so that we understand where it is in space. Now, we don't want to use the same letter twice in the same sketch because it is helping represent a location. So if we have A and B, and we put a third point in this space here, we would not want to label it A, we'd want to label it something else like C. Now, a line is a straight mark that extends in both directions without end. So there's an infinite length to a line, but no width. Now, just like a point, we wouldn't technically be able to see that, but we're trying to be able to sketch it, so we'll have lines with arrows on both ends, and we'll have points on there to help us represent a way to label this line. When we want to label it, we can either use the lower script letter, or we could use two capital print letters with a double arrow over top. So for this line here, we could call this a multitude of just 2 points that are on that line, as well as just the lowercase w. What we would not do is label it as ABC, because it is recognized that once you take and label it with any 2 points on the line, all the others are part of that line as well, especially when it's constructed like this. Now, we can also create segments, which are 2 points and all the points in between. Unlike a line, there's a defined length to a segment. Again, there's no width to it though. And we draw it by having the 2 endpoints and then a segment in between. The labeling has to be the 2 endpoints of that segment, and we put a flat bar over top of it to represent that it's a segment instead of a line. So this would be segment AB or segment BA. Either is perfectly fine because direction does not matter. However, with a ray, direction does matter because we're extending in one direction without end. So there is an infinite length to a ray, but it is in a specific direction. So when we draw it, we start with our end point and then draw an arrow and put points on that arrow to help represent that it's a ray in a specific direction. That means that when we label it, we need 2 capital print letters, but the first one is always the end point, and we put the ray symbol over top to help us represent it. So in this case, we would call this ray AB because it starts at A and goes through B. We would not call it ray BA because then we would be going the opposite direction. So do not use it. The order does matter. So let's look at the terminology we've talked about so far. We have line, which has the double arrow over top. Segment has the flat bar. Ray has a direction to it. And then if we put no type of line or segment over top, that means the length of AB, or the distance from A to B. When there's nothing over top, that's talking about a measurement. So do pay attention to how you label on your paper and in your sketches. Now, just as we can have points, lines, and planes, it's important to recognize there's relationships that exist within these as well. Collinear points are points that lie on the same line, even if the line's not visible. So say we have 2 sketches here. On the left, we have ABC, and on the right, we have a different set of ABC. And if we take and we say, well, there's no line visible, but can I draw a line through these points? Yes. And that would make these 3 collinear points. However, if I draw a line through A and B here, C is not on that line, so these are non-collinear points. And if they're non-collinear points, the 3 non-collinear points would create a plane, or make them coplanar. So let's talk about planes then. A plane is a flat surface that extends forever both in length and width, but there's no height to it. We draw it with a parallelogram, but that does not mean that it ends at the edges of that parallelogram. It will extend forever both in length and width. We just need something to show what we're representing. The labeling of it is a little bit more relaxed. It can be a capital script letter or at least 3 non-collinear points on the plane. So here we have 3 non-collinear points. We could put them in any order. Order does not matter because it still helps represent the plane that's going through there, the length and the width forever. Or we could use the capital script M. Now, just like we can have collinear points, we can have collinear objects. These are objects such as points, lines, maybe even shapes or rays that lie on the same plane. The plane, again, does not have to be drawn in to be recognized that these are coplanar objects. So let's look at an example to help us here. Now, this looks like a cube, and think about each of those sides of the cube being a plane that extends both in length and width. And let's look at some ideas of whether things are coplanar or not. Let's think about the points A, B, and C. Well, if I look, they lie on that top plane in this image. They are all included in that plane, so yes, they are coplanar. And again, to be coplanar, 3 non-collinear points automatically construct a plane, so they're coplanar. A, B, C, and F. Well, if we think about there was A, B, and C, but F is down here by itself. It does not lie on this plane, so they are not coplanar. H, G, F, E, well, that's that bottom plane in the image, and all the points are contained within that plane, so yes, they are coplanar. What about E, H, C, B? This is a little bit more challenging because there's no plane drawn through these points to see how they represent. However, if I think about it, EH is parallel to CB, so I could draw another plane straight through them, and yes, they will be coplanar. What about A, G, and F? Well, A, G, and F are 3 non-collinear points, so without even having to look and draw, I should be able to say to myself 3 non-collinear points form a plane, so yes. But I could also draw in my plane to help represent it. And again, I didn't draw a triangle because it's infinite length and infinite width. So it really is thinking about that idea of it extending like it's a sheet of paper going on forever. What about C, B, F, and H? Well, C, B, and F would be like on this right side plane, but H is over here by itself, and it's not on that plane, so we would say no, that is not coplanar.